Hello, friends. Today we're going to be doing what's called an investigation. In the textbook that I'm following, this thing is separate. It's not called a lesson, it's called an investigation. But there are elements of it that are lesson oriented anyway. But we're kind of exploring this idea of transversals and angle relationships. So here we go. To start with, just a very, very simple idea that if we have two lines and then another line or a segment that crosses those two lines, this line that crosses them is called a transversal. Okay, that's central. And it doesn't matter if these two lines are parallel or not, but just the line that crosses any two other lines is called a transversal. Angle relationships. Okay, so if we take a look at something like this, when we have a transversal, we see that there are 8 angles that are created, right? And I've numbered them here. And the question is then, okay, well, what can we name the relationships that these angles have to each other? Okay, and so here are some of the names of these relationships. Corresponding. So uh, in this diagram, corresponding angles, you can think of them as kind of in the same position, right? So angle 2, that's on the upper right side, and angle 6 is also in the upper right side. So 2 and 6 are corresponding angles with one another. Okay, and we refer to the angle itself. So we would say angle 2 and angle 6. Let's go back. Also, you can see that 1 and 5 are in the same position. So I'm going to say also angle 1 and angle 5. Those are corresponding angles. See if you can beat me to the other sets of corresponding angles. There are 2 other pairs of corresponding angles. 3 and 7 and 4 and 8. Those are all sets of corresponding angles. Okay, so um, angle 3 and angle 7 and angle 4 and angle 8. Whoops, angle 8. Another kind of relationship is alternate interior angles. When we refer to interior and exterior, what we mean is what's between the two lines and what's outside of the two lines. So any angles that are in here between the two lines are called interior angles, and all of these that are outside are called exterior angles. In fact, we can um, label that, right? So anything in this region is interior, and then anything out here, exterior, exterior. Alternate means just like switching on opposite sides. So we would say that 3 and 6, those are both interior, and they're on alternate sides of the transversal. Okay, so interior refers to like where it is in relationship to the two lines. Alternate refers to where it is in relationship to the transversal. So 3 and 6 are alternate interior angles, and 4 and 5 are alternate interior angles. Okay, so angle 4 and angle 5, and then I think it was angle 3 and angle 6. Those are pairs of alternate interior angles. Alternate exterior angles, so based on what we've said, you could probably figure that out. Those are on alternate sides of the transversal, but they are in the exterior regions. So 1 and 8, those are both exterior, and they're on alternate sides of the transversal, and 2 and 7 are pairs of alternate exterior angles. So wait, what was that? 1 and 8 and 2 and 7. So angle 1 and angle 8 and angle 2 and angle 7. Same side interior. Same side is a no expression, but interior you should be able to figure out. Same side, well, it's not alternate. They're on the same side of the transversal. So 3 and 5 are same side interior angles, and 4 and 6 are same side interior angles. So I'll label these 4 and angle 6 and angle 3 and angle 5. Those are same side interior angles. So now we're going to take a look at one of these situations where we've got parallel lines and there's a transversal and parallel lines, and see if we can find anything about the angle measurements uh, when we do this. Okay, so for this activity, what you're going to want to do is follow along, and you should have a protractor. So this is the thing that we use to measure angles. And we're going to see how these things relate. In particular, we're going to look at the corresponding angles. So the way a protractor works is you line up, so tough to get off the table. You line up this thing in the middle where this point is with the vertex, and then you set this line. You see this line goes to 0 or 180 degrees, depending on which way you're measuring the angle. And you set up this line on one of the sides of the angle. And then you look to see where is the angle on the rest of it. So I line this up 0. I'm not lining it up like this. It's not with the edge of the protractor, but instead this point at the vertex and then this line. Now I look to see, so what is the measure of angle 1 here? So I'm going from 0 and I'm going around, and I'm getting that this is about 64 degrees. And so I can write that the measure of angle 1 is 64 degrees. What about the measure of angle 2? So when I line this up, okay, and now I have the unfortunate situation where this line doesn't go all the way out. So I can't see where it goes. However, if you have anything straight, any kind of a straight edge, then you can just line it up. And I can just use my pen for this. And I can see that this is also a 64 degree. Anything to extend that line it up, and I can see where it lines up there. Looks like it's also right at 64 degrees. Okay, and so the measure of angle 2 is also 64 degrees. 1 and 2, what's the relationship between them? They are corresponding angles. And so it looks like corresponding angles, when we have a transversal and parallel lines, corresponding angles are congruent. Okay, and that leads us to the corresponding angles postulate, which says that when we have a transversal of parallel lines, that's important, right? Not all the time, then the corresponding angles are congruent. Great. Okay, so what about the other angle relationships? If the corresponding angles are congruent, then can we figure anything out about the other kinds of relationships? And the answer is yes, right? So let's go back actually to this diagram. So we know that, say, like angle 3 and angle 7 are congruent. That's kind of like what we had before. But if we take a look, angle 3 and angle 4, this angle right here, angle 3 and angle 4, those, uh, yeah, angle, you know what, wait, what's the first one we're doing here? Alternate interior angle. Okay, so let's take a look at this. Angle 7 and angle 6. These two angles are vertical angles. Remember that? They share a vertex and they're opposite each other. They're vertical angles, and we had a vertical angle theorem. These angles are also congruent. And so if the corresponding angles theorem or the corresponding angles postulate is true, then also alternate interior angles must also be congruent. Now, I was able to reason through that. I was able to kind of prove it. And so this is a theorem. The alternate interior angle theorem says for a transversal of parallel lines, alternate interior angles are congruent. Okay, so if you have parallel lines, a transversal, you can identify where the alternate interior angles are, then you can figure out what's congruent. Next one, we're going to look at the alternate exterior angles. Okay, so take a look. 3 and 2 are also vertical angles. Therefore, 3 and 2 are congruent. So that means angle 2, angle 3, angle 6, and angle 7 are all congruent with each other. Angle 2 and angle 7, those are alternate exterior angles. You know, you could do the same thing, by the way, with like 4 and 8, and then get 1, 4, 5, and 8, and see if this relationship holds for those two. But in this case, we're looking at 2 and 7. Those are alternate exterior angles. They're both in the exterior region, alternate sides of the transversal. And so that leads us to the next theorem, which tells us that for a transversal of parallel lines, alternate exterior angles are congruent. Very good, right? So now let's take a look at the same side interior angles. Uh, okay, angle 3 and angle 4, these two angles they form a linear pair. So they're supplementary, right? They add to 180 degrees. And so I'm just going to write over here Angle 3 is supplementary to angle 4. But we also know that angle 3 is congruent to angle 6. And so that means that if 3 and 6 are congruent, and 3 is supplementary to 4, then 6 also has to be supplementary to angle 4. Okay, or we could even write it this way, that the measure of angle 3 plus the measure of angle 4 is 180 degrees. But the measure of angle 3 equals the measure of angle 6. So I can just substitute the measure of angle 6 into this equation, and then I end up with the measure of angle 6 plus the measure of angle 4 is 180. Notice we didn't measure these. So this is true no matter what these angle measurements are, as long as you got parallel lines and a transversal. And then this means that 6 and 4 are supplementary to each other. Those are same side interior angles. So same side interior angles, those are always supplementary. Right. So we've got our postulate and we've got 3 theorems that we've come up with. What that means, if we go back, we can see that, let me erase this. By the way, in case you haven't noticed, I'm posting these notes that I'm doing in the description below, so you can download those, access them. But if we know even the measure of one angle here, then we can figure out the measures of all the other angles. Let's say I just tell you the measure of angle 7 is 60 degrees. Well, if you know the measure of angle 7, then you also know the measure of angle 6, angle 3, and angle 2. So this is 60 degrees. These are all congruent. 7 and 6 are vertical angles. 6 and 3 are alternate interior angles. Also, 3 and 7 are corresponding angles. And then 6 and 2 are corresponding angles. 2 and 7 are also alternate exterior angles. So those are all congruent. 7 and 8 are supplementary. They form a linear pair. So that means that 8, the measure of angle 8, has to be 120 degrees. 8 and 5 are vertical angles, so 5 is also 120 degrees. 5 and 4 are corresponding angles, not corresponding, alternate interior angles. And so they are also congruent, have the same angle measure, 120 degrees. 1 and 4 are also congruent because they're vertical angles, 120 degrees. So even just when we have this type of situation, by knowing one angle, we can then figure out all the rest based on angle relationships and the postulate and the theorems that we came up with in this lesson. What we find is that using parallel lines and transversals is a very powerful tool for finding angle measurements and doing those types of calculations. We're going to be using these a lot. Okay, so thanks for watching. Don't forget to like and subscribe.